Hello, welcome back. We're going to talk about abstract classes and methods in this segment, and I'm going to preface that by saying, okay, don't freak out. This is not something that you've ever seen before, but it's also not something that's difficult. In fact, this segment is turning out to be relatively short. So it is an important concept, but I believe it isn't difficult, and I'll try not to use the word abstract classes and methods until we actually get to writing them. So most of it will be the build up to that. And we're going to start out by reviewing what we looked at in the last video, which was polymorphism. So we have this inheritance hierarchy where the parent class or the superclass is animal, and then it has two or maybe more subclasses. We implemented dog and cat. So a cat is animal is the inheritance relationship. We also looked at the fact that you can use the parent class compile time type for variables that would refer to any of the subclasses or the subclasses. So anything that is animal can be assigned to a variable whose compile time type is animal. So anything that is animal, including dog and cat and things that inherit from those, like Siamese cat is a cat and a greyhound is a dog. So those inheritance hierarchies can get deeper, and you can still use the parent or superclasses name as the compile time type. Okay, so remember we looked at this method. We created a method in our test class that would take an animal as its parameter. And then we asked, well, what can you pass into that method? The answer is you can pass anything that is an animal because it wants an animal. So you can pass a cat or a dog, or if you have others, bird and iguana and greyhound, and anything that inherits from animal can be passed in. So now we have the other question that's associated with that. When you're inside that function and you've been passed something that is an animal, what can you do with that object inside of the function? So in Eclipse, if you typed pet dot, what would pop up? And this is the issue of the compile time type and the runtime type. If the caller of this method passed in a dog, then at runtime, this object is a dog, but at compile time, it's an animal. What we're going to do is go into Eclipse now and continue working with the same set of code, the same set of classes that we were working with before. So let's see if we can remember where we were. We have a class called animal, which is the parent class, and it has a weight instance variable, and the constructor, the accessor, the mutator, and the toString method. So we followed all the rules for object-oriented design. The data is private, the methods are public, the ones that we want people to be able to see outside of the class. And then we made two subclasses, the dog class, which a dog has a name and is an animal, and there's the constructor, the call to the parent constructor. We overrode the equals method that we inherited from object, accessors, mutators, toString. And then the cat. A cat is an animal, a cat has a name, a cat has a neutered flag. And constructors, I did not override the equals method in here. That's something that really should be done. People would frown at you if you don't have an equals method in your classes. And we have this test class. I'm going to throw away this test class and start fresh. It also would demonstrate that these data classes are reusable. Any application that needs dogs, cats, and animals can use these classes. Just as same as we're using string in every application that we build, because string is a highly reusable class. So I'm going to just close this one and go over here and make a new one that we will use for testing the abstract issue. Testing abstract might not be the good name for a class because it uses a keyword of the language in an identifier. That's frowned upon as well. If you have a variable called if while, that's probably not a good idea. So using keywords in the language in your identifiers is not something that people like too much. So what were we able to do? We're able to make an animal reference variable called pet, and then we can say new dog. What does a dog take? A name and a weight. Max is apparently a pretty big dog. Did I get that wrong? It doesn't want to compile. Oh, I put the weight first, which would make sense because it's going to get passed to the parent. Okay, and we can make cats and instead of guessing, I'm just going to go and check weight, name, and a neutered flag. So this cat is going to be 17 pounds and neutered is true. And we decided in the last one that we would make a method that takes an animal and the question that we raised is, what can you pass to this method that wants an animal? And you can pass a dog object, you can pass a cat object. Notice that when I typed pet here, I said this is a dog object. The compile time type of pet is animal, but at runtime we actually have a dog there. I'm going to make an instance of the animal class just for fun. That it will turn out to be useful in the demonstration as we go along. And an animal. There's an animal that weighs 45 and I don't know what it is. And I'll call foo and pass in that object as well. Now the question is, when you type my pet dot, what pops up? Only the things that are in the compile time type animal. So set weight and get weight are in there. Animal's a pretty simple class, but you have to kind of imagine that these things can be more complicated and more useful. Okay, so I'm going to leave that for now, and I'm going to go into the animal class, and I'm going to add another method. So in the animal class, right up here at the top, I'm going to add a public method that doesn't return anything, and it's called make noise. It takes no parameters, and it's a pretty simple method. It doesn't do anything. So now we have a method in the parent class, in the animal class, called make noise, and that gets inherited into all of the subclasses because it's public. Go back here and type my pet dot, and one of the things that happens is make noise now appears here. Even though that method has nothing in it, we've gained something. We have gained the ability to call the make noise method from an object whose compile time type is animal. Now let's go into the dog class, and we're going to override the make noise method and we will put something in it that's appropriate I don't know what I did there. SYSO control space. We're going to output woof woof. So we've overridden the make noise method that we inherited from animal, and now it does something that makes sense for a dog. Let's go into cat. We're going to override the make noise method in cat, and I don't know how to spell meow. That looks like mew. Doesn't matter. The little triangle pops up to tell us for sure that we have overridden the make noise method. So now think about what we have. Let's save all of these. And over here, when we say my pet dot make noise, whose make noise method is going to be called? Well, on the first call, the animal's make noise method will be called, and it does nothing. And then we're going to pass in a dog, and it would say woof woof, and then we're going to pass in a cat, and it would say meow meow. So what have we gained there? We have this mechanism now where we can put something in the parent class for the purpose of having it inherited into the subclass, not for the purpose of having it actually do anything. So what kind of a noise does an animal make? It doesn't make sense to ask that question, but it might make sense to say everything that is an animal makes a noise. So the purpose of this method here is to be imposing something on the subclasses. It imposes that they have a make noise method. What would happen if you didn't override the make noise method in the cat class? There would still be a make noise method. It would be the one that you inherited from animal, but it wouldn't do anything. So we're saying that we want every subclass to have a make noise method. But we can't enforce that with the mechanism we've looked at so far. So if we didn't do this in the cat class, it would still compile. Let's fix that. This make noise method doesn't do anything, and it's not intended to do anything. So let's take out the body altogether, which are the braces, and put a semicolon there. So it doesn't compile yet. We're going to make this an abstract method. So our purpose is to have a method signature here. Abstract means take out all the detail. Well, we sure did that. We took out all of the detail. It has nothing in it at all. And we use the abstract keyword, and the phone rings. Be right back. Okay, so everybody freaks out about what is an abstract class. Well, it's a class that has an abstract method. So now this compiles. So remember our purpose of this. We wanted to impose something on the subclasses. We want them to implement the make noise method. So we put an abstract method signature here, and now if we save that, that means that the subclasses must override this abstract method. And they all did. But let's just say, well, what if they didn't? Now this cat class does not compile. And the error message is the type cat must implement the inherited abstract method animal.makeNoise. And you can even ask Eclipse to do it for you. One of the things that it suggests you do is to make the type cat abstract. That's almost never what you want to do. It's possible, but almost never. We inherited an abstract method. Remember, the definition of an abstract class is a class that has one or more abstract methods. So this cat class right now has an abstract method, the one we inherited. One way we could get it to compile is make this class abstract as well. It's almost never what you want to do. So we want to override the makeNoise method, the abstract method that we inherited from animal. Okay, something's going on over here in our test class. You cannot make an instance of animal. Why not? We did before. Well, the rule is if you have an abstract class, you can never make an instance of it. What would it mean for an animal object to call the makeNoise method, which is an abstract method? Well, they decided that it wouldn't be meaningful at all. So I'm going to comment that one out, recognizing that you cannot make an instance of an abstract class. But go back to that abstract class for a second. We didn't change anything else. Abstract classes have instance variables, constructor methods, concrete methods. Those are methods that actually have a body, as opposed to an abstract method that has no braces at all, and toString. So all of this functionality is still useful. It's useful because it gets inherited into the subclasses. So you can never have an instance of animal anymore because of this abstract method signature. Let's go back to our test class. Now we have a function, sorry, we don't. We have a method that takes an animal, and you can never have an animal. That feels strange to people at first. You can pass something that is an animal, like a cat or a dog, but you can never pass an animal object because we never have an animal object anymore. You can't make an instance of an abstract class. So we have a method that is specifically designed for taking subclasses of the animal class, and we know for sure now that the animal class's subclasses have implemented the makeNoise method because the abstract animal class imposed that on them. So I think it's really not too hard. It just takes a little bit of getting used to that we had an objective of imposing this method on the subclasses, and Sun provided a mechanism for us to make that imposition onto the subclasses, and it is by making this method signature abstract. Let's go back to the slides and think about that. So an abstract class is any class that has one or more abstract methods, and an abstract method is a method that has no body, just a method signature with no braces, ends with a semicolon. Not much is different about abstract classes from concrete classes. The big difference is you can't make an instance of an abstract class. Its use is only in the inheritance of its contents into the subclasses. So abstract classes still have concrete methods, that's methods with bodies, and they still have instance variables or data, and constructor methods and toString methods and anything else that you would need in that parent class. And they impose something on the subclasses. They impose that the abstract methods must be overridden by the subclasses. And you still get to use the name of the abstract class as a compile time type. So we made a method that you could pass in an animal even though you could never actually have an instance of animal because that class is now abstract. Sometimes if you're sitting there saying, well, I understand all that, but why would I ever want to do it? There's a number of reasons. It makes the design a little bit stronger, and you might also want to do it by make an abstract class and put in a bunch of abstract methods that would describe the functionality or design the functionality of the subclasses, and then have someone else write the code. So Bob, you write the dog class, and Judy, you write the cat class. And if they don't implement your methods with the signature that you imposed upon them, then their code won't compile. So it can be used as a way of designing the functionality of the subclasses. And there's another mechanism in Java that we'll do in another video that kind of makes more sense, and it's called interfaces. It has nothing to do with graphical user interfaces, but we're coming to it. Okay, so this is abstract classes. I really continue to insist that they're not difficult. You just have to know the very few rules that there are and why you might want to use them. See you in the next video.